Hello, everyone, and thank you for joining us. My name is Rick Stewart. I'm the Chief Software Officer at DLT, a tech data company. I'm here with Matt Rose, Global Director for Application Security Strategy at Checkmarx, and our special guest, Nick Sinai, Senior Advisor for Insight Partners and former U.S. Deputy Chief Technology Officer at the White House. Welcome, gentlemen. Together, we're going to discuss how federal agencies are on a steady path to adopting DevOps fundamentals and DevSecOps fundamentals within their software development and operational processes. Yet the need for increasing levels of security is becoming more and more apparent. We'll demonstrate how agencies can embed security throughout their DevOps initiatives and gain assurance that their applications being released are secured against a broadening attack landscape. Please make certain that if you have any questions or issues, you can send your questions to the email address cybersecurity@dlt.com so we can get back to you on them. And without further ado, if we can move to the next slide, I'd like to introduce our panelist by name. And wow, my picture, I've gained a few pounds during this COVID thing. I need to eat a salad now and then. Again, my name is Rick Stewart. At DLT, I'm the Chief Software Technologist. My background is with software development primarily, but I started off in EDS decades ago, starting out in operations, and I think I played every single role in the data center. So when it comes to DevOps, and I'll get into a little story about giving some background on DevOps and DevSecOps, about how we evolved in that over the course of my career, and know innately some of the landmines with software development and as it relates to security and how technology can bridge that gap. So Nick, I'll hand it over to you.
Great, thanks Rick, really great to be here. So my name is Nick Sinai. I served as the U.S. Deputy Chief Technology Officer. I was appointed for President Obama's Open Data and Open Gov initiatives, helped start and run the Presidential Innovation Fellows Program, which brought a whole legion of technologists into government. And I was in the CTO's office when the healthcare.gov rescue happened. And so I have a lot of insights about how that helped catalyze the formation of these digital tribes, ultimately the U.S. digital services.
Terrific. Thanks a lot, Nick, and welcome. Matt?
Well, thank you, Rick. Matt Rose, Global Director of Strategy for Checkmarx. My background is really in helping organizations around the world create and manage bleeding edge secure SDLC or DevSecOps programs, specifically around static analysis and other security technologies. Been in the industry pretty much since the beginning and the concept of static analysis going on 16 years. Seen a lot of ebbs and flows and kind of pivots in terms of implementing cybersecurity technologies. So really excited to be here and just share some war stories over the past 15 years that I've kind of learned.
Terrific. Thanks a lot. And again, welcome, gentlemen. We can go to the next slide. I want to start this this webinar with a little bit of background and to ensure that we don't assume that every audience member knows about DevOps, why it came about, why DevSecOps is a natural progression of the evolution of Agile to DevOps and to collaborate across multiple teams. So to give a high-level definition, the DevOps movement is really it's the Venn diagram between development teams' activities and priorities, and with operations teams' priorities, such as availability, stability, and making sure that the workloads are up and running so it minimizes their activities. But in addition to the operations group, they are more or less involved with setting up resources so that the development team can work and provide their services. So over the course of time, and all these gentlemen, we go back a ways, and we're probably very familiar with the waterfall approach to software development, which means you go through a very staged approach of developing software because resources were very difficult to obtain. So when you obtain them, you tended to build onto them. So development teams would work in a very siloed fashion, making sure their requirements were correct so they don't waste cycles. And then by the time any of the stakeholders, meaning end users, perhaps testers, a line of business people, actually saw the working software, it was in a testing environment provisioned by the operations group. The reason why that's important is because these chained events, these time sequences of handoffs between building the software and then deploying the software over a course of time builds up a bottleneck within the operations group, who has to provide the resources for the development team to run and test their software. So naturally, when developers are running very, very fast to deliver services, they usually end up giving instructions to the operations team late and giving them instructions on how to deploy their software. And in the process of doing that, it creates a consternation, the proverbial wall between these two groups, because usually that handoff is late, perhaps miscommunicated. The procedures are usually muddled or not very clear. So over the course of time, if this continues to happen, as the operations group starts to look back at the development group saying, A, you're giving me workloads too fast, and B, when you give me workloads, there is an issue with those. So I want to give a very brief history of an experience in the private sector before I joined DLT with my history, and I hope not to put people to sleep. I'll expedite it. When I first started off with the EDS way back, we had a very, very siloed approach to delivering software. There was like 9 volumes filled with activities that would, quote unquote, allow you to deliver software functionally and securely. When I left EDS, I had an opportunity to move to a small company to deliver entertainment systems for be a white label entertainment system for US carriers. It actually was pretty successful. We had a group of very experienced and talented developers. So we knew how to develop software correctly. We didn't institute bad coding practices because we were pretty safe. However, the .com hit. Well, we still experienced the time, the handover to operations, because they were still in that very phased of procedural driven mechanics in delivering software. Now the .com bomb hit, and our little company went down to 10 people. And in a way that was an extremely advantageous thing to do or to experience, because every one of those 10 people were experienced in all phases of the software development lifecycle, including the operation side. So if we can go to the next slide, all the different high-level activities that we were performing, we were responsible for, so that wall was removed. So it wasn't a handoff between another team. We were all collaborating together, which is kind of the essence of DevOps. It's having your development teams, which includes your line of business, your testers, your marketing and salespeople, working in conjunction with the IT operations group to provide resources when they're needed, and also to support the application workload once in production in front of end users. And you also, the operations group was also the last person in that pyramid. When things go bump in the night, or things are vulnerable, or you have defects, they're the ones getting called in order to rectify the situation, even though if that problem was originated back in the development team. So getting back to my story, when we had this small team of very experienced people that were cross-functional, we operated in the DevOps culture unbeknownst to us, because the DevOps keyword wasn't even around at that time. So things went along swimmingly. We were actually making a lot of money. We were growing. And part of that growth was we were bringing in new developers, new people into that engine without teaching them and giving the proper experience for developing software properly. So we ended up having some operational issues. And moreover, if we can go to the next slide, we ran into both our internal and external security teams. This is what it's like. We were making progress, and then all of a sudden, bam, we were denied at the goal by a security team saying, you can't launch this software now. It has inherent security vulnerabilities in it. And if those vulnerabilities were to be exploited, where our companies, multiple companies are at risk. So we went through the phases of change. We went to denial, we argued, we said, no, that's never gonna happen. They don't know what they're doing. If they're inside our firewall, then they passed all of our security checks and it's not really our fault anymore. Once we took a step back and said, you know what, these are our problems, because there is no escaping the fact that if we blow a hole in the side of the boat that other people are in, we're all going down, not just one team. If we can go to the next slide, please. So we adopted the shift left security mentality, meaning when the security team came forward and said, you have these vulnerabilities, you need to fix those, we quickly identified that we had to take development steps in order to ensure that we're not instituting these vulnerabilities from the software perspective. And if there were like network equipment or some server equipment, that would be on the operations group. From the software itself, we were responsible for injecting the right controls, the right checks and balances, the right scans, so that we could be assured that not only the software was secured, but we wouldn't be called in the middle of the night in order to rectify defects and rectify security related issues. And again, most of all, to lose our reputation as good software providers. So if we can go to the next slide, please. So this whole DevSecOps concept comes from the fact of security is involved with every aspect of the software development lifecycle. It's not just an operational side. It's not its own entity. It is a cumulative set of activities and controls that have to be instituted at the right time, at the right place, in an efficient manner, so that the entire DevSecOps teams provide high quality, secure software, and moreover, have the ability to remedy any vulnerabilities or defects quickly. So the essence of DevOps is to speed up the ability to deliver software. The essence of DevSecOps is to be able to maintain that speed, but also maintain a security posture as well. We can go to the next slide, please. So I'd like to start off with some of the questions, and I hope I didn't bore anything with that background, but it's my wife always tells me, don't assume anything when you're delivering information. So I always listen to my wife. So with that, Nick, I gave an example of the private sector, and those activities and those examples are still the same and prominent in the federal government, if not more so. Even though ours was a commercial or a financial or a revenue related hit, in the federal government, there is still loss of reputation, et cetera. So what in your opinion is driving the shift to DevSecOps in the federal government?
Yeah, so I think there's three things, Rick, that I would call out. One, there's been a big push for IT modernization and digital transformation. And that certainly was the case when I was in the Obama administration, but it's also true in the current Trump administration. And so you see this in a variety of kind of administration-wide documents. You see it in department or agency-wide initiatives. So like the President's Management Agenda calls for IT modernization, the Defense Authorization Act. You see CIO strategy documents from the DoD CIO and other federal CIO. And you see the Defense Innovation Board, which is it's a advisory council to the DoD, but it very clearly calls out the need for IT modernization and digital transformation. And the second thing I think that is driving DevSecOps in the federal government is this greater emphasis on the customer experience. That is, how do we deliver the kinds of capabilities that the end user is expecting? And it's a greater recognition that software is critical to meeting those ambitious and elevated set of expectations, right? And COVID, in some cases, has accelerated that. There's this saying of software eats world and software eats government too, right? And so we're as end users, and whether those are veterans or students or service members or people down on their luck or small business owners, whoever it is, they have greater expectations on how the government is going to be able to deliver. And so that means that ultimately the government has to figure out a way to deliver those kinds of capabilities faster, right? And then the third thing that I think is driving DevSecOps is there's a greater emphasis on open source software. It started in the past administration with the source code policy, and you've seen a continued focus on this use of open source. And there's a lot of great tools and products, but it also raises some vulnerabilities as well. So those are three things, and I think it's the meta piece of it too is that the government is not supposed to be separate from private industry. That is government sometimes lags private industry, but if best practices are, generally speaking, that there's been a shift from waterfall to agile and waterfall to DevSecOps, then you're seeing that happen and play out across the federal government.
Who you're seeing is pioneering these agencies, and I agree with everything you just said. And before you answer that, actually, it crystallizes it. I went to an industry day where the Navy was given a demonstration on how they wanted to offer this award out, and they're giving all their the requirements basically. But they had a captain in the Navy who came up and was emphasizing the need for speed, but at the same time, the speed had to be balanced with security, because he said the adversaries, we used to have a large technical advantage over the course of time, but that technical advantage has narrowed significantly to the point where he crystallized it for me, saying, listen, if I'm in the middle of the Mediterranean Sea, surrounded by adversaries, I can't wait 2 weeks for an application change. So not only is that application needs to be done fast, it has to be done securely, or that adversary might take advantage. And again, we're talking about loss of life for a warfighter. So that's what made it very, very prominent in my mind.
Yeah, it's interesting you bring up the Navy. That was actually going to be one of my examples. They're doing some really exciting work. They have a compile to combat in 24 hours program, a C2C 24. And so this is a Navy-wide platform, which I think it supports something like 1,400 users today, but is growing to 5,000 users pretty quickly. And the Navy's been talking about a 15% reduction in time and cost associated with application development. And to your point, Rick, is ultimately the DoD needs to be more responsive to the threats, and that means that software is going to continue to change, and that means we're not going to build software the way we build warships or battleships or aircraft carriers. The Air Force has also been a pioneering agency here, and so there's a flagship software development effort here in my adopted hometown of Boston called Kessel Run, and they actually have a number of other software factories, including Bespin and Space Camp and Level Up, and so on and so forth. I think in the IC, the NGA has been a leader in the space. They, in fact, recently published a roadmap, somewhat unusual for an intelligence agency, but there's a heavy focus on software development. And so it's really interesting. I encourage all the listeners here today to go check that out, because that's fascinating. And then on the federal civilian side, USCIS and GSA would be two of my favorite examples of agencies that have moved to the cloud faster and have moved to a faster pace of application development. Yeah,
and interesting you say that, because cloud and there's a bunch of technology that are automating a lot of these processes, when now you're getting an exponential delivery mechanism, but it also has to balance, again, the needs for the security and ensure your software is hygienic. So it's interesting. I've talked to a lot of those customers, and you are dead on. They are leading the group, and in my estimation, all the other agencies will follow their lead and their examples. So how does that impact the federal workforce themselves, and perhaps even the contractor workforce, which is significant within this space?
Well, I think there's an increased emphasis on technical skill set in both the federal workforce and the contractor workforce. And you see this in the kinds of things that USCIO Suzette Kent has been talking about, right? And you see this in the president's management agenda. You see this in a variety of those documents that I talked about earlier. There's a call for software developers. I mean, the Air Force is bringing that back as a military occupational specialty. NGA is talking about the need for software developers. And so this is going to be a continued theme. And these agencies are talking about software development, modern cloud technologies, including containers, but there's also a heavy emphasis on cybersecurity, right? Because we can move things to the cloud and we can use containers, which is great. But if we're not securing those, or to your opening example, if we just have security at the end of it and then have to go back to the beginning, like that's not going to be a very effective or efficient way to do things.
And it's a loss. It's a waste of taxpayer money at the end of the day. So it impacts everybody.
Yep, and I think we're going to see more transparency for the workforce. That is, we're going to have kind of more a shift from certifications, which will still be important, but a focus on the actual skills and recognizing that those are dynamic things, right? And then finally, I think there will be an increased focus on multidisciplinary teams as it relates to this topic. I mean, that's the whole idea of Agile and DevSecOps, is to bring together different disciplines, right? To bring the developer and the operations and the security professionals together to continuously build and deploy secure code. And I think the recognition that we need to have multidisciplinary teams where security is embedded in those teams, and not just a check or an office at the end, or a paperwork exercise, which I think is, of course, traditionally where a lot of federal government has been.
Yeah, I completely agree with you. There's a continuous X principle in DevOps or even DevSecOps, where everything is in the infinite loop, so to speak. And one of that is continuous learning. And there has to be continuous learning because adversaries are finding ways to get into the software, finding attack vectors and exploiting those. So it has to be a constant moving target, not only for the providers of perhaps the open source software, but the developers themselves. They have to keep up to date with changing vectors. Let's put it that way. So appreciate it, Nick. Matt, do you want to add anything before we get into some of the pointed questions for you?
No, I just think to reiterate kind of the graphics you represented with DevOps and the cyclical nature, or the bow tie, or the infinity loop. We no longer have the structured areas for specific type of testing. And the thing that you really need to take away in the federal government is that typically in that infinity loop representative of DevOps, something is happening at every one of those steps at every time. So based on the aggressive nature of release cycles, just the overall project management of software, that is constantly evolving and constantly moving. Software is now a living, breathing thing, and there's not set patterns where in the end you'd have step 1, step 2, step 3, and you only have one activity in one step at one time. Now the fluid nature is happening at every one of those steps all the time, and it's really driving continuous feedback to make your software better and more responsive to the needs of the end user.
Totally agree. I'm going to shift now and talk about bridging the gap between private and public sector, which we kind of talked about at the beginning through a collective private sector experience and how it affects the public sector and how that gap is now narrowing, if not being dissolved. So Matt, I wanted to ask you, where does the security tend to clash with the DevOps requirements? I think you touched on it just briefly in federal agencies and elsewhere.
So the biggest thing is that security technologies, application security technologies specifically, have to complement the processes of DevOps. The first mistake organizations make is, okay, we have this DevOps program, it's highly automated, it's highly effective, and now we're going to introduce security. Security has to be baked into the process from the start, and it doesn't have to be on the left or the right or the middle, it has to be everywhere. And one of the biggest barriers to success is that, oh, this is a security build, and I have to configure my DevOps process differently. I have to do some out-of-band activities to allow for security to happen. That's the biggest mistake, is that security has to complement DevOps. It almost has to be transparent to the DevOps flow. It needs to leverage the effectiveness of the release cycle, but not delay it or cause additional steps that could really, slow down the process that is highly customized to be very quick and effective.
I completely agree. What are some of those obstacles in your mind that can be overcome either through automation technology or through training?
So the biggest thing is when you talk about security technologies, they're configured in a certain way, usually by a security policy, which really is the fuel to the security technology, saying you need to look for these types of vulnerabilities in this application. One of the biggest issues I see is, federal government and private sector buy the bleeding edge piece of technology, integrate it into the DevOps process, automate the process, but then turn every type of vulnerability on. So you're actually creating too much noise. You're creating too much information. And sometimes you're the boy who cried wolf. You're basically raising red flags all over the place, which totally defeats the purpose and the intent of DevOps. The speed of DevOps can't be derailed by somebody saying, you have an issue, you have an issue, you have an issue. So the security policy that is really the fuel for the program needs to be very concise for the risk of that application or piece of software that's being built. I find that 5 to 10 things of critical value or critical risk are where you start, you baseline applications, and then you adjust the policy. One of the cool things that you think about in that infinity loop is you actually are getting real data and real metrics from the program itself, which not only allow you to build the software better, but really to tailor the security policy you're looking to enforce based on real world findings. And again, that's one of the things. The automation is very powerful, but it can be too powerful and produce too much information that really kind of clouds the whole process associated with DevOps.
So what in your opinion are the key, just before I ask this next question, just a clarity for the audience, there is kind of like a consternation within the community about DevOps versus DevSecOps, because if you're from the camp that says DevOps, security is already baked in into that word, into that culture, that's a valid statement. That's where I really came from, is security is everybody's problem, not just the security team. And then there's a camp that says DevSecOps has to be in there because you have to overtly say security in there so that people keep that top of mind. And then people say, well, it should be SecDevOps, et cetera, et cetera. So we're using it very liberally back and forth within this conversation, just to clarify that either one from our three perspective, and I hope I'm not speaking out of turn, is it's security is in there anyway. So whether you say DevOps or DevSecOps, it's to us, it's the same thing.
Yeah, and I talked to a lot of thought leaders on both the government side and on the private sector side. They assume that their process has security in it, because really what DevOps is about the automation and integration of tooling to build software in a more effective way. That tooling incorporates many different type of technologies, from source code management systems to build platforms to binary repositories. There's many different technologies. Security should be part of that equation. And if you bolt it onto the side, you've totally defeated the concept of DevOps. And I had a few concepts that people don't like DevSecOps as a term. The reason being is some people that are not familiar with the terminology or familiar with the processes think that DevOps and DevSecOps are two totally different things.
Yep,
and they're like, "Whoa, is this the DevSecOps initiative or the DevOps initiative?" And really, sometimes when you put that security moniker on something, a security bug, a security process, DevSecOps, it becomes very scary. And people are like, "How do we deal with this? Is this something different?" So really, I feel that DevOps has security baked in, but sometimes we put that special, asterisk or star of security in there just to really call it out. but really any DevOps program with all the tooling associated with it should include security on a daily basis. And it should be
I agree.
just
There
from the
are some that are very violent about their opinion about this, and it's actually funny to say. It's almost like an IDE or integrated development environment. You can't pull that away from someone. They just will argue ad nauseum about the term, and it really, at the end of the day, we're talking about injecting security earlier in the process. So basically, when we're talking about technology, automation, et cetera, what are the key application security testing solutions required for a successful DevOps or DevSecOps program, in your opinion?
So really, there's really four main disciplines of DevOps. You have development, CI, CD, and production.
Right.
And a lot of times people think there's a silver bullet for security that fits in one spot or the other that really, makes sure that an application is secure during development. But the technologies you need to think about, moving left to right from development is static code analysis, scanning of the source code. When you're actually talking about the build phase or the automation phase of putting the software together, maybe the CI orchestration phase, you talk about incremental static analysis, which is scanning the source code just based on the diff from one release to the next, software composition analysis. As you move to the right of the DevOps disciplines, your CD arena, that's where interactive application security testing occurs, dynamic analysis occurs from a tooling standpoint, manual pen tests occur, and then you have the whole question of the right side of the production environment where you have web application firewalls and runtime application security self-protection and container security. So all of these really go together to formulate a true DevSecOps program, and really they all provide valuable information about the risk within that piece of software, because the component of code as it moves from the development to the CI to CD to production is changing in itself, and there's certain vulnerabilities that exist at only one phase, and you need to basically correlate all that data together or those findings together to really find a correct path to remediation. Because one of the biggest mistakes organizations make is they're great at identifying risk, but they're not really clear and concise on how to remediate the risk. And you need to basically create something that focuses the attention, because there's only so many hours in a day and so many resources available to fix that bug. Let's do it smarter and not just act from a busy body standpoint and just look at everything and not really know where to start.
I think a fantastic answer. I'm fascinated. I was reading some statistics about, and still to this day, and this was decades ago, SQL injection is still one of the highest penetration or exposures or vulnerabilities that coders are still putting into their source code. So I don't. Can you speak a lot? Are you seeing another trend outside of SQL injection, cross-site scripting, or any of those types of, let's say, methods in which more junior or less experienced developers are not aware that they're exposing their code to?
So there's really two answers to that question. So yes, those two types of vulnerabilities have a certain categorization. They're a data flow type of vulnerability. Right. So you have an entry point and execution point, a source and a sink, a beginning and an end. And those are the vulnerabilities that are very difficult to identify, because the only way you can actually truly find those if you look at the code as a complete entity. A lot of times software development is segmented into silos, especially in the modern world development. Software is very complex. It's millions upon millions of lines of code in some cases, with open source components and dependencies and all those type of aspects. So yes, SQL injection and cross-site scripting and anything with a data flow still exists, because a lot of times it's very difficult to trace that entry point to execution or source to sink in a consistent way. And one development team is not any worse than another. They just don't have the whole picture, so they can't really respond to the risk because they only see, the first 3 chapters of the book, and the other team sees the last 3 chapters of the book. And if you just say, hey, is there an issue, or please tell me the whole story, they only can tell you the story of the piece of the book they have in front of them. And really, software is a living, breathing thing. It kind of exists and constantly evolves. It's an extension, a copy, a branch of itself, then it rejoins the main branch. And it's very rare that you have one individual that understands the entire software application or user interface or whatever that is on a day-to-day basis. That's why you need something that's a holistic approach that looks at all the code, all the components to really find those type of vulnerabilities. Really, I think what we're struggling against is just the raw size of software applications, and their complexity kind of makes it like a needle in the haystack to really find these vulnerabilities. And that's why multiple technologies throughout that DevOps flow from an application security standpoint are needed, because there's not a silver bullet. There's not one spot that will find everything. They need to complement each other and then cross-correlate that data to find the vulnerabilities that you're talking about.
That is, thank you very much. I saw the stitches on that fastball. That you led me in perfectly to my next question, which was, you're talking about the developers at this point with maybe static application security testing, but now with the ops side, you're now talking about dynamic application security testing, where you're actually deployed your code. Now you want to see how it's operating in real life, where their ports opened up, et cetera. So can you speak to a little bit about dynamic application security testing?
Yeah, well, we call it DAS, Dynamic Application Security Testing, which is usually a tooling that basically crawls websites or web-based applications and throws hacker methodologies and sees what comes back. The problem with that is, in a modern DevOps world, is it takes a ton of time.
Yes.
You know, if you have a multi-layered application that you have to follow every link throughout the application, it could, honestly take days to completely crawl and throw all that hacking methodology at a running application, which is kind of inverse to the whole concept of DevOps.
Yes.
That's where a modernization has really come, and you can read the industry analysts, this is associated with the public and private sector, that interactive application security testing has the same type of result set, but it leverages an existing process you already have, which is your functional testing. And you don't have to crawl, you're basically just watching the flow of data from inside the application rather than outside the application, and really produce very, very viable results that can then be completely understood by the person that's responsible to remediate the vulnerabilities. It's a very, very interesting thing to think about, that new technologies, older technologies are evolving to support the DevOps initiative, just like static application source code scanning has incremental scanning nowadays. We have the concept of software composition analysis for the open source packages, and then the modernization of dynamic testing is really interactive application security testing. Or if you move into the production arena, the modernization of a web application firewall is with runtime application security self-protection. So it's like technology imitating life. So the security technologies are basically trying to keep up with the platform they're responsible for, which is DevOps. So they need to adjust their lens on things, and they don't work the way they did even 3 to 5 years ago.
I agree, and you're touching on great topics, because I think one of the key aspects, and I touched upon it earlier, the old axiom: you give a man a fish, he eats for a day. You teach a man how to fish, he eats for a lifetime. That's very apt in this environment, because one of the goals in the DevOps or DevSecOps culture is the continuous learning. How do you approach teaching people what the vulnerabilities are, and actually killing the vulnerability at its source, which is the developer who would put it there in the first place?
Well, again, it's a chicken and the egg situation there, where again, the developer may not even know that they're introducing a vulnerability, because they don't have the entire picture, the entire code base, the entire data flow. So, but they are tasked with remediation of said issue. So one of the modernizations that has really come out of DevOps from an application security standpoint is the modernization of Appsec training for developers. So no longer is it effective to say, hey, everybody go take a 1-week class in out of context, out of the office about SQL injection, cross-site scripting, any vulnerability you're talking about, because then they go back and they may not need that knowledge for 3, 6, 12 months, hypothetically. So we need to modernize the training to drive remediation that's basically instant on. So developer training needs to be available to them when they need to use it, rather than out of band or out of process. Just like the security technologies associated with a DevSecOps program need to be in band, training needs to be in band as well. So if a developer's tasked with fixing, say, a SQL injection, and they're not familiar with the proper steps to take, they have the ability to take a very concise module that basically is focused on their immediate problem. And again, that's the modernization of another concept of security, which is developer training, to basically support the flow and the execution of a DevOps initiative.
It's fantastic.
Yeah, I just want to plus one that for a second, if I can, Rick. You know, this idea of training being just in time, being in context, being on demand and as you need it, not just for developers, but I think for operations professionals, all kinds of IT, and even creative professionals, right? I think it's tremendously important that we move away from, you know, physical classroom type of certifications where, you know, the developer's trying to remember, oh, what was that app security thing that I'm supposed to remember, versus actually getting to the knowledge just in time, and it makes all the difference in my mind.
Yeah, I agree, Nick. And one of the last things we'll touch upon before we open it up for questions, as we see the industry maturing and proliferating in terms of types of languages that are supporting, the architectures that are being employed, like microservices, we're going to see lots and lots and lots of applications, whether they're back-end facing, UI facing, et cetera. So the proliferation of the amount of applications and the types in which they are constructed as, can you speak to the ability for a security testing apparatus or technology that can support many different languages and constantly looking at the landscape and see what developers are using and what they're trending towards? Because the traditional Java is great, fantastic, but the movement is going into different languages.
I'll take a stab at this. So
Matt.
there's definitely, I mean, I'll start with a story, and we'll go at it that way. I remember I was giving a presentation. I was a presentation at a DoD audience, and I said there's, you know, 90% of the organizations out there have a DevOps initiative. They're constantly they're moving down that path to a DevOps a program. They have initiatives, they have programs, and then 10% feel they're fully baked. And this could be commercial, or this could be DoD or public sector or something like that. And I had a captain from the cybersecurity division of the Air Force raise their head and said they're full of it, because the tooling is not there to support all the different permutations of DevOps. And all the permutations of the languages we're seeing are basically kind of being dictated by IoT, by mobile, and we don't even know what these languages are. Google comes up with a new language that people want to use because it's better for the mobile platform. You have specific industry languages. Yes, you have the tried and true C, C++, Java, .NET, but there's a lot of cooler technologies out there that serve a specific purpose. And I think we haven't even seen the end of these new languages based on the need, just like we haven't seen the end of the tooling capabilities to make DevOps more efficient. So again, it's wait and see, but you need to basically stay forward thinking in the implementation of your DevOps program and the implementation of the language you're using to write your software or applications, because there may be a better way, more secure way based on what is coming out. And again, it's a constant ebb and flow, and staying ahead of the curve is important. But again, looking at technologies that support multiple potential platforms, multiple potential languages are very important, because there is a kind of best case scenario for certain languages for certain use cases.
Agreed. I think we're running out of time, gentlemen. I want to open it up for questions. And any parting thoughts before we take some questions from the audience? Nick, do you?
Yeah, I had a quick point, and that is we're also seeing the accreditation processes change, and I think that's a really important shift, right? And so you see the Air Force with their fast track ATO process, right, which is more designed for cloud-based systems and cloud software. But we can't institute DevOps or DevSecOps and then have this traditional big bang ATO process of let's write a several hundred-page PDF, bless it once, and then come back to it every 3 years. It really has to be more of a continuous process and a continuous monitoring. And so we're getting away from that big bang ATO. But we still have a ways to go in federal government, candidly.
No, it's a fantastic point, and I think we touched on aspects, but it is becoming more prevalent, this continuous ATO concept, and NIST needs to get involved. We have industry standards and whatnot, and they need to keep up as well, because if they are going to put controls in place and compliance and governance things, they can't be behind the curve. They have to be ahead of us. Matt, anything else do you want to add before we open it up?
Yeah, I just think it's very important to think about, what the industry analysts are saying about the AST space, application security testing, in that in the end, a lot of these analyst reports used to come out just on the capabilities or findings of the product. Did you find SQL injection better than the next person? Did you find OWASP top 10 better than the next person? Now it's more about the capabilities to fit in a modern DevOps world. So the biggest questions that are being asked is, can this automate into my process? Are there APIs to move data between different systems and maybe do better metrics, KPIs, correlation? So really, it's interesting to see that it's not just about the capabilities in terms of finding vulnerabilities, it's about how it works in your environment. And the analysts are getting a lot of requests and are writing a lot of information in their annual reports around, is this security technology fit for the modern development world of DevOps?
Terrific. Well, gentlemen, I can't thank you guys enough for this session. Very informative, bridging the gaps between multiple different sectors and bringing your expertise. I had a great time doing this, so let's open it up for questions. So we've got some questions that were raised during our conversation. And the first one was from Heidi, who says, is a NoSQL database a better appliance to use than a regular SQL database? And I'm going to direct that to you, Matt.
Yeah, I mean, there are definitely some benefits to using a NoSQL database. But again, that's only one aspect of a much greater ecosystem of an application. So you think about the database aspect, the coding language aspect, the platform itself, the intended user experience platform, they all kind of work together. So just looking at a SQL versus a NoSQL database is really not looking at the whole holistic aspect of the security, because most of the vulnerabilities that we're seeing today have a data flow, a beginning and an end, a source and a sink, and they're all related together. So that may be a step towards a more secure infrastructure, but it is not by all means an end-all be-all solution to replace good application security practices throughout your entire DevOps process.
I agree with you. And the next question that came up is kind of on the same note, so I'll direct it right back at you, Matt. How do you containerize a .NET Core with web forms and web app into a dev test prod pipeline with Selenium Tests and Jenkins or GitLab CI/CD pipelines? It's kind of an amalgam to what you just said about a holistic approach to implementing security.
Well, I mean, we're definitely seeing a shift in the industry as a whole. I mean, we'll take a step back in time from a history lesson, from a waterfall structured environment to a DevOps process that's really architected to a cloud native environment, when you're talking about cloud and different implementations and how code is never truly brought together until it's in a running state. So when you think about the integrations and automations of application security testing technologies, they have to be at pretty much every one of those technologies that were kind of mentioned in the question. There's different technologies that work at runtime. There's different technologies in terms of application security testing products that work in pre-compiled code. There's certain ones that work for software composition analysis and open source code. So to think about one area, and I believe the major kind of question was around cloud and infrastructure associated with cloud. That cloud is the end game because that's what it's deployed to. But there are many facets that lead up to that, and the integrations and automations of security testing products have to be thought of in a very strategic way, because the entity, which is the code itself or the building of the application, is different at every step. So you need to provide different testing practices to be holistic in your approach and not very narrow and only look at one aspect of cybersecurity risk.
I totally agree with you. And you hit the buzzword with the holistic. It really means from everything, that's the whole supply chain up. So you just can't concentrate just on the workloads. It's got to be the infrastructure. Everything has to be looked at in its entirety.
And that's kind of goes in line with, people love the term shift left has been around forever. Well, I'm a proponent of shift everywhere, because the left, the middle, the right, there's all different types of risk and vulnerabilities that propagate themselves at different phases. So if we're only looking at the left or the right, which would be the CD arena, which is deployment to a cloud or deployment to another infrastructure, you have to be very cognizant of all those stages. And if only focus on one, you're going to miss things, which you're going to be, have a false sense of security in terms of risk.
I completely agree. And I know I'm picking on you, Matt. This is one that you'll take the first part, and Nick, I promise I'll get to you on the second part of the question. So, how do you adopt security into a DevOps culture? Get buy-in from leadership, educate developers, get a security vulnerability less environment, infrastructure, and build that culture. So Matt, I want you to talk to the adoption, maybe the education, the infrastructure part, which you kind of touched on those last couple of answers. And then Nick, follow it up with the leadership environment and culture.
This is a big question. I mean, we could do a whole webinar just on this question as it sits. So I'll try and give the 30,000-foot Cliff Notes view. Really, when you're thinking about the culture and the implementation of cybersecurity technologies, I think the major way to approach it is that cybersecurity or application security testing technologies has to complement the DevOps flow, however it's configured with whatever tooling or technology you're using to physically build the code, write the code, build the code, deploy the code, and then integrate into those areas based on modern kind of processes around automating different types of testing, static analysis, software composition analysis, runtime analysis, be it in a dynamic setting or an interactive application security testing. And really, to make sure that the culture is acceptable is you communicate what you're concerned about and only be the boy who cried wolf when there's a major thing that needs to be fixed, because you don't want to be a derailment to the process itself, to the success of the program, which is releasing very, very quickly based on minute changes. And if security is too noisy and too much of a barrier to success, it's going to be pushed back on, and you're going to have a ineffective culture per se within your organization.
And I would only add on to that, I think is a great answer to performance testing, because I think there's a lot of vulnerability that are exploited when your workload is under load, and whether your infrastructure exposes some vulnerability. So completely agree. And Nick, I'll shift to you for the leadership and environment and cultural aspect to implementing security into DevSecOps.
Yeah, I think Matt hit it exactly of how do you bake security into all of these pieces. And so part of that is getting a traditional security apparatus and the leadership that sits on top of that comfortable with this continuous coding and continuous integration, continuous deployment. And so it's helpful to have a risk official who understands this and spends time with the group. I think the Air Force is a great example. The Chief Security Transformation Officer, Lauren Knossenberger, really leaned forward with Kessel Run and got to understand the process and was able to kind of start some of the traditional compliance paperwork in parallel rather than wait till it was all done. I think that's kind of a mind shift of, hey, we have a very paperwork-based process at least in the Department of Defense, but this is also true in the federal civilian side as well. And how can some of those things happen in parallel with this process? Because we have to move away from this kind of big bang approach of we're going to build stuff and then we're going to have this big bang authorization where everyone's going to accept risk. So how do you get this to be kind of a real-time exercise, and that the data from this risk process is almost produced on demand rather than you having a bunch of contractors build the static security plan that someone is going to bless from high. That doesn't make a lot of sense. And so how do you get those progressive risk officials to understand that they're actually not accepting more risk? They are actually able to have better visibility because you're consistently or constantly assessing risk rather than doing it in a very static document where the system has changed, the external threats may have changed, and so there are risk officials inside government agencies that understand this. And I think for anyone who's trying to do this from a leadership perspective, it is bringing them along and showing them the DevOps process and environment and getting them comfortable with it in the earliest of days. Like I don't think this works of like, let's set up a big DevSecOps initiative and then invite the traditional assessors in at the end, because they're going to just try and put something at the end. Is like get them to understand how this is a shift from the beginning. And I think they would be more willing to work in a continuous process And yes, that's going to be security tools that are integrated into the whole process, but it's also going to be thinking about how they can not put this kind of really time-intensive gate after the fact.
Yeah, I think you hit it on the head, and it's interesting when you were talking. I think risk management is probably one of the most misunderstood concepts in all of either software development, particularly in the public sector, because we're so risk averse by doing anything. There also is a risk for not doing anything and being analysis paralysis and trying to figure out what's going to possibly happen when you don't know. Where DevSecOps is more of a continuous learning with the guardrails of having the ability to back out anything that could potentially be vulnerable. So I think it's a culmination of not only technology, culture, but also assessing risk in the right framework. Terrific. In order to be fair to our guest, how can we better implement security in DevOps cycle or DevSecOps cycle? And Matt, I think you've answered this probably 4 times, probably in the last couple of questions, but I'll give you one more additive answer to that so that we respect all of our questionnaires.
No, sure. And I mean, I think the biggest thing I've mentioned is the integration of application security technologies, the automation of the integrated technologies. But I think the thing that you really need to think about when you do that integrated automated process is, what is the security policy I'm looking to enforce? And a lot of times companies buy bleeding edge security technology. It doesn't matter what the technology is actually configured to do, but they turn on every rule and checker and just find way too much information. And as you just mentioned, it almost becomes analysis paralysis. I have too much information. I have subjective conversations on false positives versus false negatives in different technologies. So when you actually implement a application security testing program, make sure that the policy is very clear, concise, and granular for the things you're looking to remediate, because you just get lost in the weeds if you look for everything under the sun.
Very prudent advice. I completely concur. And we'll end up, we've got one more question, and I'll direct it to you, Nick. What are your recommendations to budget for long-term support of DevSecOps? Especially in the public sector, it's very, budgeting is a whole animal in and of itself.
Yeah, we could have an entire webinar on the color of money and the difference between capital and O&M and the distinctions. I mean, we should be thinking about what are our ongoing investments in security, and those are going to be people and they're going to be ongoing software investments. And clearly, when it comes to software tools and platforms, you want to make sure that you're budgeting an ongoing amount. Software has largely moved to a subscription model, and so it's important to be thinking about this rather than a big buy, but actually thinking about ongoing costs. I think it's important to think about platforms that have the breadth and enterprise scalability that can cover a lot of languages and a lot of environments, et cetera. Especially if you're at the budget level and the enterprise level, then you really should be thinking about something that is going to work for a number of different environments, so that you have a single platform or a series of platforms that are able to help your developers. You may have multiple software factories. So I know the Navy has a C2C 24 where they're trying to set up a standardized set of tools. The Air Force, through the Chief Software Office, is also trying to set up a set of standardized tools. It's not to say that there's one tool, but that there's a series of standardized tools that you can provide to your enterprise. And it's just budgeting for that scale and scope. And then to remember that people and training is also incredibly important too. And so when you think about budgeting, you do have to be thinking about the workforce side of this too.
Yeah, I think you hit the nail on the head from my perspective, because it's not you train your developers and they're good to go. It's a continuous vector, the attack vector, that keeps changing. You've got to keep your workforce up to date all the time, not only on new languages that are emerging, but also existing languages that they might be quite familiar with that now have a vulnerability. They need to be constantly educated. So budgeting for continuous training is probably one of the biggest things that I see. Well, I can't thank you guys enough. It's been very entertaining and very informative over the last hour. Thank you for your patience for all these questions. They're great answers. And I'll give you back the rest of your day. So our viewers, thank you very much for spending the time. Nick, thank you. Matt, thank you. And look forward to continuing webinars in the future.